Okay, so for this assignment, we're talking about section 8.5, which is all about adding and subtracting rational or fractional equations. One of the things you have to realize and think back to way early, okay, in your experience with mathematics and fractions, is that when you have something like 3/4 plus 2/3, you can't physically add them the way they are because they don't have a common denominator. It means that the pieces don't fit together correctly. So we need to split them into things that do have a common denominator. So if I look at the 3 and the 4, okay, the LCD, or least common denominator, would have to be 12. 3 and 4 both go into 12, and I want the smallest number I can that both of them go into. So that means that I'm going to have to multiply the top and bottom of this fraction by 3, the top and bottom of this fraction by 4. What that does is produces 9 over 12, which is an equivalent fraction to 3 over 4. Plus, over here I'm going to get 8 over 12. And then now that they're both in 12ths, I can answer in 12ths. So the denominator is going to stay consistent all the way across, leaving with 17/12. And this is not a question from the homework, but it is telling us exactly how we have to proceed through the homework today. Finding the lowest common denominator, the least common denominator, is key to doing the assignment. So we're going to start with one that's already set up for us, beautifully ready to go. We'll look at question number 7. Now question number 7 says 5x over x plus 3 plus 15 over x plus 3. Okay? Now they already have a common denominator, which means I can just answer with that as a denominator. The key here is to realize that we're being asked to take 5x and add 15 to it. Well, 5x and 15 are not like terms, so they can't physically add. So I'm just going to write 5x plus 15. Now, whenever I get to this step, we would normally, we'd say, oh, well, we're done. Well, I always want to look to see if I can factor. The stuff that we did in 8.4 is still relevant, so we want to think, can we factor this top, for instance? It looks like they both have a 5 in common, making the top be something that can factor. And so the top, what would 5 times what gives me 5x? Would that be x? And 5 times what gives me 15? Well, that'd be a positive 3. And something really cool happens for this problem that doesn't happen for all of them, but does in this case. The x plus 3's cancel, and we get 5. So the actual answer for adding these two expressions together is just 5. Everything else goes away, including the denominator, which is a really cool thing. Now, as far as most questions would probably have stopped right around here, and they would have been, oh, that's the answer, in the story. But because it's simplified, we wanted to go that extra mile. Let's go ahead and look at some that aren't set up as perfectly for us. So we're going to look at number 20. Okay. Number 20 has the equation 3 over x plus 4 minus 1 over x plus 6, I believe, x plus 6. Okay, and so I want to combine these. Well, the first thing I notice is that while I had a common denominator in question number 7, I don't have one down here. And if you try to say, oh, well, I have a matching x, well, x plus 4 is not the same thing as x plus 6. And while the x's are the same, the addition makes the number of the numerator or of the denominator in each problem change. So what I'm going to do is I'm going to put parentheses around addition problems or subtraction problems if they were. So x plus 4 is now one thing. X plus 6 is now one thing. If you think about the LCD, it's not about having x plus 4. It's not about having x plus 6. It's about having both of them. Similar to when we were back here, and 4 wasn't the common denominator, 3 wasn't the common denominator, but both of them together gave us 12, which was the common denominator. So my LCD for this problem, I'm just going to list it so I always remember what it is x plus 4 times x plus 6. It's that combination together. Okay, so that's what I'm shooting for my LCD. When I come back to the original problem, the question might be asked, well, what's missing? what's not in this denominator that's in the common denominator? Well, it's missing the x plus 6. But what you do to the bottom of a fraction, you have to do to the top of a fraction. Okay? So over here on the right, well, what's missing? Well, it's missing an x plus 4 on top and bottom. Okay? Whatever you do to the bottom, you have to do to the top. Now, if you look, the denominators of both fractions are identical. They're identical. They look exactly the same. So what I'm going to do, I'm going to write out my two fractions again. Okay. The minus sign between them. Okay. 3 times x is 3x. 3 times 6 is plus 18. And instead of writing the two parentheses out each time, I'm going to get really lazy. I'm going to write LCD because I already stated what it was. If you want to write x plus 4, x plus 6 each time, that's fine. I'm going to write in my answer, but along the way I can remind myself I have the LCD. Here's where a little bit of a hiccup comes. 1 times both of those is x plus 4, but there's this subtraction that I have to do when I combine them. What I prefer to do is make that plus and make the 1 negative. So I'm going to do that down here. A negative 1 times x is negative x. A negative 1 times 4 is negative 4. At this point, because I have an LCD, I can just add like terms. So I see 3x plus a negative x is 2x, and 18 plus negative 4 would be 14 over x plus 4, x plus 6. Now I always want to look back and make sure that I can't factor still. Well, look at the top here. Both of those numbers are divisible by 2, meaning my final answer should be 2 times x plus 7, because that would give me the 2x and the 14, over x plus 4 and x plus 6. Does anything cancel? Nothing cancels, and there's my final answer. We have to develop this idea of a common denominator to be able to solve these problems. Well, let's look at just two more. One that's very similar to what we were just looking at, and one that's a little more complicated. Let's look at number 27. 27 has x over x squared minus 9. Okay, and we are adding x plus 1 over x squared plus 6x plus 9. So first thing I want to do is I'm going to factor the denominators so that I can look for what the LCD would be. Over here I'm going to have x minus 3 and x plus 3. So that denominator's gone. I've replaced it. Over here I have x and x. The factors of 9 that add up to 6 would be 3 and 3. So x plus 3, x plus 3. And that's gone. So when I go to do the LCD here, I have to be careful. I want you to think about, I'm going to come up with a couple of numbers I want you to think about. Let's pretend that this number here was 4, and this number here was 6. 6 is made up of 2 times 3, and 4 is made up of 2 and 2. If you aren't careful, you'd say, well, let's use 6 as an LCD. But you can't, because you need to get 4 and 6 to go into the same number. 4 and 6 both go into 12. Well, let's talk about what's in the 12. There's a 2, which represents that. There's a 3, which represents that. And I need another 2. If you look at 12, 2 times 3 is 6, times 2 is 12. I couldn't double count here. That's where a lot of people end up with an issue. They try to double count one of the parentheses. So if I don't use I don't double count the parenthesis from the same denominator, I'm going to use an x minus 3. And there, it takes care of that one. I'm going to use an x plus 3. And I can use that for this parentheses and one from this over here. I can't do it for both, so I need another x plus 3. Okay? If there's 2 of them from the same denominator, then I'm going to need 2 of them. Okay? So as I go into the next phase, the question is, what does this denominator on the left not have that shows up in the LCD? Well, the LCD has two x plus 3's, so I need another x plus 3. That makes my new fraction, x times x plus 3 over x minus 3, x plus 3, and another x plus 3. I got an extra x plus 3 in there by making the top have an x plus 3. Plus, and this is a little messy, you gotta use parentheses here, x plus 1 over, well, what was missing in this fraction over here? It was an x minus 3. And then, of course, I have x plus 3, x minus 3, x plus 3. Okay. So I had to come up with these two right here by putting one on top and one on bottom to be able to complete the fraction. At this point, I'm just going to write LCD whenever I have the denominator. Let's go ahead and clean this up. I have x squared plus 3x over the LCD plus, this is a little bit harder, that's x squared, that's minus 3x, and this is plus 1x. That's minus 2x and minus 3 all over the LCD. Well, I want to combine all my like terms by addition, so I'm going to have 2x squared plus 3x and negative 2x plus 1x minus 3 all over my LCD, which is x minus 3, x plus 3, x plus 3. You could write x plus 3 quantity squared, or not. It's not the end of the world, whichever way you see it. Now I would like to see if the numerator factors. So I'm going to try to factor. It's going to have to be 2x and x. And the factors of 3 are 1 and 3. So I'm going to just start plugging things in. I want to put the 3 here and the 1 here. This is 3x. This is 2x. If the 2x is negative, which I'm allowed to have one of them be negative because of the negative 3, then they would reduce to a positive 1x. They would add up to 1x. So that's good. I need to make sure that the 2x ends up being negative, so I'll put negative there and a positive there. And then, all right, x minus 3. And then I'll write x plus 3 quantity squared. Because nothing cancels, I'm stuck right here. So the idea is we take from both fractions, their denominators, and we try to compile them into one denominator that's manageable and something we can work with. All right, the last question is dealing with what's called a complex fraction. When we deal with complex fractions, all it means is that there's fractions inside fractions, and we need to get rid of that idea. So question 31 is the one we're going to look at. And once you approach it the same way every time, your life will become a lot easier. It's x over 3 minus 6 over 10 plus 4 over x. 10 plus 4 over x. We got these fractions inside fractions. And what I'd like to do, okay, all I really want to do is make this into one fraction and make this into a single fraction. If I can make the top into a single fraction, make the bottom into a single fraction, then I'm going to be fine. So up here, I'm going to make this 6 over 1. What would the common denominator for the top be? The LCD would be 3, because 1 and 3 both go into 3. So that makes it x over 3 minus times by 3, 18 over 3, or x minus 18 all over 3. Great. That gets us a lot of the way there. For this one, the LCD would be x. It may seem a little strange to have x be a common denominator, but it is. If I multiply by x, I'll get 10x over x plus 4 over x, which is equal to 10x plus 4 all over x. Now that I'm over here, this is a fraction divided by a fraction. And whenever you divide fractions, you flip in times, making the problem x minus 18 over 3 times x over 10x plus 4. Okay? What we just did is we flipped the second fraction upside down. And so now what we're going to do is we're going to try to factor out anything common and simplify. Across the top, there's nothing common. So I can just have x and x minus 18. Across the bottom, right here, this is divisible by 2. So I'm going to change this for 2 times 5x plus 2. What that does is it allows me to multiply the 3 by 2 to make 6 times 5x plus 2. Now instead of having fractions built inside of fractions, I have one fraction. It may still not look as happy as you want it to be, but it is a nice, clean, compact fraction. And that's it.